Hello. How are you doing? Oh, good. I can't hear you. I'm sorry. It's not because you're on mute. It's just the large room you're in right now. So, okay, if my picture is going to be on that side, let me move this a little bit to the side. Okay, that's going to be much better. Cool. So function orchestration in the world of serverless. That's what we're going to talk today. I'm not going to talk about myself. We got some information on the slide earlier that can kind of give some ideas about who I am. And if you want to get in touch, I guess the best way is Twitter. We're going to have some time at the end of the session for Q&A for sure. But, if something comes up, after you have a sleep tonight and tomorrow you have some more questions, feel free to reach out to me on Twitter. And with that, I'm going to remind myself that I need to speak a little bit slower. Okay, cool. So let's start. So we got two different ways when it comes to, serverless. And we're not going to do, this session is not about, how to build, a function or two or maybe three. This session is about, hey, what if I have a bunch of functions and then how I'm going to manage all these functions, especially from a Microsoft perspective, the Microsoft platform perspective, because, I'm not going to go into the discussion of what are functions versus containers, what is functions versus microservices. That's definitely loud discussion, but we don't have the time to do that. But, in short, think about, you started building, you started experimenting with functions, you got one or two, and then you you ended up in a situation where you have we have hundreds of those. How are we going to manage? Is there some way to, make sure these communication between the functions are some tools that can help us to look from a higher level? And what if I'm going to build a flow or, any particular business flow or whatever, right? You have a process that has to consist of multiple functions. Is there anything that can help me out to have a higher level look and manage those processes? So that's kind of the topic when it comes to function orchestration. And we got two different tools. And like everything else, I feel like there's always high-level tools and low-level tools, right? There are high-level programming languages, low-level programming languages, and they all have their place in our world. And when it comes to function orchestration as well, we got two different tools. The first one is Logic Apps. Logic Apps is for those who like to have, interfaces, some user interface, or they like to define things through definition languages, right? Markup languages, instead of writing code that defines those. So having a UI is really beneficial. But again, it depends to the audience who is going to orchestrate these functions and what is the end goal, right? And we will talk about that. The other one is durable functions. Durable functions has an orchestrator in it that helps us orchestrate different functions by simply writing C# code. Durable functions is available on Python and JavaScript as well. I'm not sure if I'm missing a language, but pretty much it's actually a library. It's not part of, it's called Azure Durable Functions, but at the end of the day, it's just a library that exposes functionality on top of TPL. And I'm kind of stopping myself because I don't want to go very deep, but it's not a feature of this service itself in terms of platform as a service, Azure Functions, right? It's essentially a NuGet package that you add that might rely on some of the underlying infrastructure services. And I'm going to call, Azure Storage in this sense is an infrastructure for durable functions. So it might rely, some of the infrastructure services have dependency on Azure or might not. We have some flexibility there as well. But at the end of the day, it's just a library you add to your product that helps you manage your functions and orchestrate them. So that's kind of the high level look into these two different tools. And with that, let's start with durable functions because I feel like it's a little bit more fun. So durable functions helps you build stateful functions. That's very important, right? Because a function is supposed to be stateless. So you have to, every time you run it, it should not persist its state, right? You should not be able to, if you have 2 or 3 functions, for example, you have to pass the state from one function to another, right? So you don't need that. with durable functions, as the name suggests, they are durable. So they're going to stay there and persist their state. We will talk about that. We're going to have some demos. So they will manage the state for you. They will create checkpoints when your functions have to be paused. There's going to be automated checkpoints, and those functions will be restarted for you. And there's going to be a playback of your code restoring your checkpoints on the way without rerunning the same process again and again. So for now, it might be a little bit confusing. I'm sure when we see the code, it's going to be more clear. But again, the high level thing here to understand is it helps us manage the state of the function. It stores the state on its own, some magical process behind the scenes, right? And it's able to take checkpoints of the function, because one thing that is very important when it comes to serverless development is the fact that you only pay for the amount of processor time that you use and for the memory that you use, right? I mean, in the case of Azure Functions, the unit of measure for billing is gigabyte per second and per millisecond, actually. So it's critically important for me to be able to pause functions if, for example, they're going to wait for something, right? And on that sense, it's important to be able to store its state. I mean, all these things, by the way, these are things that we can manually build, but obviously it takes time. And what durable function does is to help us to get all these things running pretty easily. And then throughout all these features, we end up being able to build, stateful workflows, essentially. Right? Workflows that consist of multiple functions that can, be paused, resumed, replayed, and all of those operations will be handled by the underlying framework. So that's kind of the high level. So we mentioned workflows. So let's go a little bit deeper, right? In durable functions, we define our workflows in code. There are no JSON schemas. There are no designers, which are features you get when you go into Logic Apps, for example. If you need some JSON code, defining the workflow on a markup, or having a designer, Logic Apps is the way to go, and we will look into that at the end of the session once we're done with the durable functions. And those functions, the workflows, they can call other functions synchronously. They can wait for it, or they can call asynchronously in a fire and forget fashion. And the output from one function should come back to the other function, right? We should handle that traffic as well. And the checkpointing will be automatically done. Let me look at my slide to see if I missed anything. One interesting thing here is, and we're going to see the code, but for example, let's say you're running a function asynchronously. I mentioned like in a fire and forget approach, but asynchronous, for example, the await doesn't necessarily mean that we're firing and forgetting. Await means we're waiting, but not actively waiting. Anyways, I'm not going to go into it very deeply. But my point is, imagine that you are, when you await something, right? Your source thread, for example, let's say we are doing, asynchronous programming in C# today, right? We are calling something where that's an asynchronous function, and we are using the await keyboard. What happens is that we free up the initial pipeline of the thread, right? And then, instead of attaching a callback or anything, we simply say await. We free up the current pipeline, and the processor or the thread can be used for something else, right? That's kind of the idea. And when the results come back, we are able to reinitiate that thread, or bring that thread back essentially and continue our flow. So imagine you are able to do this with a function that is hosted over the network on the other side of the network, and that is exposed through HTTP. So imagine you want to call an HTTP endpoint and you don't want to wait for it. And the original caller is able to save its state, save a checkpoint, die, right? Free up the processor so you don't pay for it, because every millisecond you are paying for it. So your function is calling another function. Meanwhile, your function dies, its checkpoint is saved. You don't pay for its processor. Right? The remove function executes, runs, or it does whatever it do. Once the remove function is done, it calls back, and your original function starts from scratch it starts a playback process. It goes through the lines of code, and it is able to restore all of the, states that were initially stored, and it is able to resume to the point where you actually code the third-party function or whatever that is, a removed function, and then you get your response and continue with your code. So this is what actually happens. And we're going to look into the code right now. But before we look into the code, I have a couple of patterns that I want to talk about. The first one is an easy one. This is a very classic problem, right? We got a list of functions, and we want to run one by one by one, function chaining. So usually what we do here, and let me move this here, what we do here is, you simply put some kind of a queue between all these functions and you're done, right? But it's still a bunch of work. I mean, putting items into the queue, then polling the queue for new jobs, and, serializing, deserializing, all this stuff. So it's a lot of work, and there's a lot of complexity around retries and error handling and stuff. So what if we did this with durable functions? How would that look like, right? So let's see. So I'm going to go out of presentation here, and I'm going to run Visual Studio from scratch. Okay, there we go. So I'm going to create a new project. So for all the other demos, I do have ready examples, but for this one, I wanted to start from scratch so that you know how to get to this code, because I will be using a template that comes with Visual Studio actually. So I'm going to create an Azure function. Is this location good? I'm not sure. Yes, it is good. It's going to be function app1, doesn't matter. And I'm going to say create. So the next question will be what type of Azure function you want to create. In this case, and let me see, I can zoom in. Oh, if I zoom in, we're losing our transcription. Anyways, so I'm going to scroll down and pick Azure Durable Function Orchestration Template. There we go. Okay, this one. And I'm going to say create. Yeah, that's all I'm going to do. It is going to create an orchestrator for us. It is going to spin out some code that is ready to run, and that is a very good example of function chaining. Let's give it a moment. Oops. Okay, here we go. So again, I'm not going to go into what Azure Functions is and what Serverless is. I'm going to leave it out for now. But let's start from here. Most probably the NuGet package is being restored right now. Okay, there we go. So this is the first function we should look into. So when it comes to an orchestrator, in this case, just for the sake of the example, there is an HTTP function, essentially an API, that is going to start the orchestrator, right? The orchestrator is supposed to run multiple functions and orchestrate, obviously, right? It's going to be the mother function, if it makes any sense. It's going to be the primary master function, or whatever you want to call it, main function. But the main function, the orchestrator, can have multiple instances as well. So this HTTP method, when we call it, it's simply, calling the starter, which comes with the iDurable orchestration client. Okay, these are all injected into our code. This is the way to use the durable client that comes with the durable functions. And again, it's just a NuGet package you include into your function application. And then we are saying, hey, I want to start an orchestrator called function1. Okay, and I will pass no data to function1 for now. You can pass some data if you wanted to the orchestrator. For now, there's no data. Okay, so we are simply getting the instance ID, and we are returning a status response back. Here's the thing. When we run an orchestrator, it's asynchronous, right? The orchestrator can take days to run. We don't know. It depends on your implementation and design. There's this concept of eternal orchestrator that lives forever, right? Because of the fact you're able to suspend and resume. You can have you can actually even build actor model on top of this. So, and there are examples for it, by the way. It's not just a random example. So durable entities is something we're not going to talk today, but definitely worth discovering if you're into it. So long story short, we are starting the orchestrator without getting the instance ID. And this method actually returns back a set of information as the response of the initial HTTP call, right? That helps us communicate back to this orchestrator from outside. What does from outside mean? From outside world, whatever. It gives us a set of information, a set of HTTP endpoints that helps us go and talk to this orchestrator directly from outside the environment. We will look into this. But for now, the important thing here to understand is an HTTP function that runs an instance of an orchestrator called function1 and returns some endpoint information related to that. Okay, that's it. Let's scroll up. Actually, let's look at this. So this is what's called activity function. Activity functions are the functions we orchestrate. So there is the orchestrator and there's then activities. Okay. So this one is an activity and it doesn't do anything. It simply, gets a parameter called name and says hello back. That's it. There's no, nothing complex in here, but it's the activity function. It's the one we want to chain, right? You can have multiple of those. In this case, there's only one. So that's why if we look up here, you're going to see that we are calling the same function 3 times, giving different names, city names. So we are saying hello Tokyo, hello Seattle, and so on and so forth. So we are calling the same function sequentially in this case, but this could be different functions as well. And this is the orchestrator. So let's look at the orchestrator. What does the orchestrator do? We didn't pass anything to the orchestrator, so the orchestrator doesn't have any data incoming, so that's okay. We will see that in another example though. So the orchestrator simply, let's kind of try to read the code, right? What happens here? Okay, we're calling an activity async. We are saying, hey, I'm going to send you a string, and this is the name of the function. Okay, cool. And this is the parameter. Cool. What is this context? It comes from Durable Orchestrator. Okay. It's simply my orchestrator is telling the Durable Functions runtime that it wants to call a function, an activity function, and it gives it the name and the parameter. Why the name? You might be like, hey, the function is down there. Why are you giving the string name? I mean, obviously there's a better way to write this in C#, but the idea here is, this function and this orchestrator, they are not, there's no guarantee that they will be living in the same app domain, in the same isolation, is in the same server, in the same physical server. There's no guarantee. This function app, when it scales, right? So in short, this call is a call over the network. This is an HTTP call. And this is going to call, this is going to go through the load balancer, through the, scaler. And this will find an instance of function1 hello and run it. And if I run this a lot, this function1 can scale independently from the orchestrator. Okay, even though they are in the same, C# file, they're in the same assembly, their scaling will be, conceptually different. So it looks like we are sequentially running this function 3 times, awaiting them one by one, and finally we're returning the output. That's what this orchestrator does. And this is what function chaining is. It's as simple as that. You don't have to worry about anything else. Here's the trick though. Let's run this. Okay, I'm going to click here, put a debug point if I can. Okay, and I'm going to run this because I want you to see something firsthand. Come on. Give it some time. Oh, I had to move this back, right? That's why sorry about that. Okay. Please. I'm not sure why it's taking so long. Okay, there we go. So we got the endpoint. Okay, so this is the way I can run this function. And here's what I'm going to do. I'm going to open a VS Code. I'm going to simply send an HTTP GET to that one. But in order to do that, I will be using VS Code. Where is the endpoint? This one, HTTP function start. Okay, let's go here. Oh, this is the same, right? Okay, cool. Oh, my plugin didn't. Yeah. Okay, give me some time. Give it some time. It sometimes take a while. There's this beautiful plugin for VS Code that can do that can send HTTP requests, and for some reason It's taking a while to load it. Usually I was supposed to see a button up here. Why it's not working? Okay, there you go. We got it. Okay, great. Can I click that now? This is all because I am streaming and doing all that stuff at the same time. Okay, so I've sent a HTTP request. Great. So we hit the debugger. So here's my point. I'm going to put another debugger here to the activity, right? And I will hit F10, okay? F10. So now when I hit F10, you're going to see the activity start, right? F10 and go there. Okay, we got the response, by the way. Orchestrator started, right? So let's go back. And this is the initial response that we get from the HTTP call. You can see that there are, there's a, I'm sure you can't, unfortunately, you can't read that because it's too small. But anyways, so these are HTTP endpoints that helps me communicate back to the orchestrator. We will talk about that. But for now, you can see that, hey, we got the debug point hit for the first activity. Let's look at the parameter here. It says Tokyo. Great. So I'm going to hit F5 now. Okay. So we did run this line, right? And I'm going to hit F5, which means I'm going to, let it go. You expect, I guess, by default that we will go here, right? We will be done, return, right? Let's see. I'm going to say continue. Let's wait for it. Oh, we got here back. Why is that? So here's what's happening right now. The code is replaying, okay? We started from scratch because the orchestrator just resumed, and we have some state for the orchestrator that has to be filled in. So let's see, F10, the first function. This function was already called, and we already know the answer for it. It should be hello to Tokyo, right? So right now, when I hit F10, the activity function should not be called. I'm hitting F10. It didn't. The activity function wasn't called. So let's look at the collection. We got one item. Let's look into it. It says hello Tokyo. There we go. So the response from the activity did come in. And the second time this orchestrator was resumed from the beginning, it didn't call the same function again, but it was able to fill in the output of the activity function back. It was able to feed that back in. So now when I hit F10 again, because we're calling with a new parameter, the activity function will run. So I'm going to say F10, and you're going to see the bottom breakpoint hit. There we go. So this time the parameter is Seattle. So I'm going to hit, say continue. It's going to resume again. The orchestrator will resume again. Those are called playbacks. Okay. So you might be thinking, hey, I'm kind of paying 3 times the execution. So here's the trick. That's very important that you don't do any heavy lifting in the orchestrator. If there's any heavy lifting that has to be done, it has to be done in an activity so you don't replay that. But whatever you do in the orchestrator is going to be replayed. So that's what's really important. So I'm going to say F10. There we go. Outputs list 0. Now outputs list is 1. So I'm going to hit F10 again, and outputs list 2. So now it's time to call the activity trigger again because we didn't call this yet. So I'm going to say F10, and we will hit the breakpoint again. Cool. We got the London, and I will say continue. So this time, this is the final playback. We will hit the orchestrator again. Let me remove this breakpoint for now. Come on. No, I don't have any errors. I'm not sure what's happening. Executed. Oh, yeah, there we go. Okay, my PC is suffering right now. Anyway, so we got the output list is null. So I'm going to hit F5 because, okay, let me leave the breakpoint here. So let's make sure the activity is not going to run at all this time because all 3 instances have sequentially run. I'm going to hit F5, and we're at the outputs. The activity didn't run at all, and I got all 3 results. So this is the magic behind durable functions. And this was only sequential. Okay. So let's go. Where's my PowerPoint? Cool. Okay. So this was function chaining. Just for the sake of the example, I just, screenshotted the code and put it into the slide deck as well. You can download these slides. I'm going to share the link at the end of the presentation. And here's the second pattern. And this pattern is, let me put this somewhere in here, somewhere, fan in, fan out. Okay. So fan in, fan out is that you got a function that, that spits out multiple jobs, for example, right? Those jobs can be run in parallel so that you can speed up things. And then you have to consolidate all of them back into a single function, which is the tricky part. I mean, imagine I'm telling you, you have 3 HTTP endpoints to call. I want you to call them in parallel, to start calling them the same moment. And then I want your code to resume when all 3 have results back. So it's not rocket science, but it's not very easy to develop either if it's over the network with all the retries and stuff. So how can we do that when it comes to functions? Okay, I'm going to pass in some code. I'm definitely not writing. It's pretty easy, by the way. It's just for the sake of time. I'm going to replace this and put this in. Okay. So I guess you already saw how easy this whole thing is. Simply don't await for every task. Just wait them all together. That's it. That's all I have to do. Durable functions will take care of the rest for me. So let's test it out. Oops. Okay, debug point here. I'm not gonna put a debug point for the activity trigger this time. Just look at let's look at the playback counts for the orchestrator itself. We got the endpoint. Come on. And in this example, I'm just doing a fan out directly from the orchestrator. Okay, let's go. Send request. Go back to Visual Studio. It says executed. Okay, we got the endpoint head. I'm going to say F10. And I'm going to say F5. Okay, first playback happened. The initial launch did happen. Now I got the second. Okay, so I'm going to say F5 and we're done. So the orchestrator ran only twice. That's it. Because we are not running sequentially, it called all of the, let's look at the output, right? We got 3 items in there. Okay. We got 3 tasks. So this is the fan out. This is crazy. And here you can call this function like 100 times. It doesn't matter. And the beauty of this is because this function is an Azure function, if you call it 100 times, essentially you're running all of them in parallel. And depending on the amount of, functions you have in parallel, you will be actually, forcing the Azure function runtime to scale. Right? Because, Azure functions scale per the amount of events it receives. So this is like a crazy scalable solution to fan out without, with the minimum effort that I can imagine, to be honest. Cool. Okay, at this I think it's gold. Hope you did too. Okay, here's the third one. Eternal process. And sorry about moving the subtitles, transcriptions there and there. I should have designed my slides, to leave it some space. Okay, so eternal processes. So these processes are long-running processes. They need to have their built-in management of the state. And in this case, we can actually use the orchestrator client with its built-in webhooks as well. And they can run essentially forever. I will show you an example for that, but I want to combine it with something else. Okay, so and that is the fourth problem. All right, there you go. Human interaction. Okay, I'm going to put it there. So in this case, we got an orchestrator. It has to do something. It is running some functions and so on and so forth. But at some point, you need some manual intervention. I mean, you have to have some kind of a third-party API or something, a third-party system. You have to wait for it to interact with your system to continue, okay? Or maybe not. You should maybe even have a timeout. So have a timeout, but on the other hand, have some external system to ping you as well so that your orchestrator can continue to the flow that you have with the other function executions that you might have. So let's look into this. I have a demo on this one as well. So here, I'm going to move some more code. Okay. This time I'm going to replace on the disk section. Okay. So what did we do? First off, let me import the appropriate using statements. Okay. So here, let's see what we're doing. So in this case, the scenario is that you got some text message provider and you want to expose an endpoint for them to say, to let you know if you received text message validation. Right? And if you don't receive a text message validation for 20 seconds, you still want to continue your process or, maybe branch out into a different flow, right? So here's what we are doing. We have the cancellation token. So long story short, we have a timeout task. So remember, we are actually working on the task parallel library. It doesn't matter, how that task is internally implemented. Does that task represent a thread on my machine, or does that task represent an activity, a function, right? It doesn't necessarily matter from a C# API perspective. So in this case, here's what I'm doing. I am having a timer created for myself, a timeout for 20 seconds. This is a task. And then I have an external event task. But keep in mind, both tasks are actually being created out of this context, which is my orchestration context, sorry. I'm going to explain why. So this is kind of obvious. This is an external event. I want the durable orchestration runtime to listen for. It's going to be, the name of the event will be SMS challenge response, and I'm expecting an integer to come to me for that endpoint. So this is going to be one task, and the other task is the timeout task. And I'm simply saying, hey, when any of these happen, one of these happen, let me know. And then I'm going to do something else, which in this case, I'm doing nothing, but this is just an example, right? So create timer. It's kind of important because I'm creating this timer task out of the orchestration context, because if you think from the perspective of time, it's every time the orchestrator plays back, it is starting from scratch and the states are being restored. But what about time? So if you call UTC date time in your code, during your replay of your orchestrator, that will change. And you might not want that, because essentially you want all of the state in your function to be restored, right? So the activities are being restored. What about UTC time? That can be restored as well if you ask the date time from the orchestrator. So the orchestrator will know that, hey, this is a playback instance, so I better give the same time that was originally requested on line 1 or 2 or whatever. Right? So you can still call the regular UTC date time and you will always get the up-to-date time. But, if you want your code to be stateful, even from its start date time perspective, obviously you have to ask the time to the orchestrator, not to the machine it's running. And this is kind of the same reason with the timer as well. We are creating the timer from the orchestrator. We will let the orchestrator manage the time differences and so on and so forth. And these can be, 20 seconds, minutes, days, whatever you want. So this is what the eternal orchestrator is about. So yeah, let's run this one. Let's run how this is exposed to the outside world, because this is where we're going to look a little bit deeper into that response that the initial HTTP call creates, right? Remember that when we run the orchestrator for the first time, we get some response back. That response is what we're going to look into this time. Okay, great. So I'm going to go back to VS Code, and send a new request. So do I have that? I am not sure. I guess I do. Okay. Oh, it's still running the, what? Oh, okay. We got it. We got it. But I didn't see the right-hand side refresh. So I'm going to do that again. Sorry about that. It says executed. Most probably this is going to wait for 20 seconds. So let's put a debug point here. Okay. Okay. Timeout task completed. Great. Let's look at it. Yeah, this one's ran to completion. 20 seconds timeline completed. The challenge response did not complete at all. So I'm going to hit F5, continue, and complete this. I'm going to go back to VS Code. Not sure why it ran twice, by the way. Anyways, so I'm going to send an HTTP request and run the orchestrator again. But this time, I'm going to show you the right-hand side. Actually, before calling you, let me show you the right-hand side. So these are the URLs we're going to use when we talk. This is the response we get when we call the orchestrator, right? So, and this is send event post URL is the URL we're going to call to, call back that SMS challenge external event, right? This is the URL that we are going to call. So I'm going to start a new one. Okay, we run that. I'm going to copy the event URL. I have to do this in 20 seconds. Otherwise, the timeout will kick in. And there we go. And I'm sending to send request. Great. Did it succeed? It did. And here. Yeah. Okay, let's look at it. Do we have the timeout task completed? It says it ran to completion. Was I late? What was wrong? I guess I was late. Okay, let me try that again and send a new one. Copy. Oh, I did not replace the name of the event. So that's what it was. That's why it didn't work. We need to replace this here. And now it will work. Yes, it did. Okay, let's look at it. Timeout task didn't complete. Challenge response. Yes, it did. And the result is 2. Great. We got the answer as well. And continue. So this is how you can interact with the orchestrator. And this is how you can have a function that lives, an orchestrator lives forever, right? And you will not be paying when the timer runs, right? It's not actively running. So you will not be paying for the processor time where your function is asleep, is paused and it's waiting for the timer. So it's really a nice way to have eternal processes. Okay. With that, let's see what else we have. Okay, this is just a code example again, just copy paste to document stuff. So there are a couple of important rules when it comes to orchestrators. I kind of mentioned with some of those, but your orchestrator function will be replayed multiple times. The outputs from other activities will be remembered, will be stored. By default, Azure Functions uses Azure Storage to do all that. We have alternatives if we want to have. You don't have to rely on Azure Storage for that, but that's what it comes by default. And let's look at the 4 warnings I have done there. Never write logic that depends on random numbers. Yes, because every time it's going to, during the replay, it's going to be different. Datetime now and the GUID generation. Instead, use the APIs that come with the orchestrators. Never do I/O directly in the orchestrator function because it's going to happen. It's going to be re-executed every time that you have a playback. If you have some I/O that has to be done, just put it into an activity trigger and call that so that it can be, it doesn't get replayed, right? You just get the output of it and continue. Otherwise, you will in the case of our first example, we had the 4 replay essentially. So you would be doing the same I/O 4 times, which will be costly. So definitely put the I/O into activity triggers. Do not write infinite loops. There's another method to do that. We can still have eternal processes. use built-in workarounds for, yeah, we did kind of mention the workarounds for 1, 2, and 3. So those are the warnings I wanted to put out there. So durable task framework engines, I want to mention those as well. By default, it comes with Azure storage. It's the default backend. It's serverless. It's no low cost. But then there is this durable task netwrite. The storage subsystem is pluggable. Netwrite works on top of event hubs with the faster library, if you know about that. But long story short, it's 10x the performance. Okay, so you can definitely replace that. And the other subsystem you can use is SQL Server. If you are, I mean, maybe you heard about that. Azure Functions is something you can run anywhere you want. You can run it on AWS. You can run it on on-prem. You don't even need something like Azure Arc, but if you have it, that would be beautiful. But if you don't, the worker and the scaler, all of that is open source, is out there. You can download, you can install wherever you want. You will have your own portal and stuff. And when you do that, obviously, you don't want to depend on Azure storage, and you can use the SQL Server provider to do that. Okay, let's jump into logic apps. So logic apps, we did talk about that a little bit. We want to use them when we want to have a UI on top of a design surface for complex business flows and processes that we want to orchestrate. And it's much easier, right? And it's much easier to manipulate as well. And one of the benefits of logic apps is the fact that you got a huge amount of managed connectors. So you got connectors for enterprise systems like, I don't know, Exchange, Office 365, Twitter, Facebook, and all that stuff, right? Stuff that you most probably don't want to write code for, I suppose. So anyways, those are the values with logic apps. I'm going to try to speed up a little bit because I want to show you. Okay, the first thing I want to show you is, and let me stop this. Close. Let's get a clean slate. The first thing I want to show you is a function, actually a durable version of this story. So in this case, I mean, this example in real life might not make sense. This is just for the sake of coming up with an example. Okay, so in this case, I have a function that does image processing, uses Azure Cognitive Services to do image processing and detect if there is food in a photo. I told you, it's not very innovative. But anyway, so I'm calling this the image food analysis because I am on a diet for a while. For me, it's important. If there is a food in an image, I don't want to see it. Okay, anyway, so here we go. So this is the activity. The activity, this is the HTTP function that runs the orchestrator. And when I run the orchestrator, I actually pass in an image URL list. So for this orchestrator, for this HTTP function, because it's an HTTP function, you can actually send an array of image URLs. I get those image URLs and I can send it to the orchestrator because what I want the orchestrator to do is to fan out and process all these images, in parallel. That's what I want to do. And I'm using the free tier from Cognitive Services, and free tier from Cognitive Services is a limit that says you cannot do more than 20 transactions per minute. And, I want the orchestrator to take it slow as well and not go overboard. Okay, so that's kind of tricky. Okay, so I'm sending the image URL list to the orchestrator and starting it. That's it. So let's look at the activity. The activity is actually calling the NuGet package for Cognitive Services. It gets an image URL. It sets up the computer vision client, and it says, analyze image async. And if there's food, it returns the image URL. If there's no food, it doesn't return the image URL. It returns null. I mean, from an API design perspective, those are not the examples you want to, rely on. Anyways, so that's what the activity function does. And let's look into the orchestrator. So the orchestrator gets the image URL. Okay. A lot of the plumbing here is to make sure we can page through multiple batches of, in this case, 10. So if I have 20 image URLs coming to the orchestrator, I take the first 10 and I start calling, the image analyzer in parallel, and I say wait all. Okay. So I get the current time from the context. I see how much time we have spent processing those 10 images. Okay. I put the ones that return, that have food in it, into a separate list. I'm going to talk about this. Let's skip it. So this is the list of images that have food in it. And then I, remove my current page and I run the same orchestrator again after waiting for 60 seconds less than the amount of time it took to process the first batch. Okay? So here, this calculation is important. Okay? Every time I call this, it's going to get a new date. This one will not. It's going to be snapshotted. After the wait, when I call the API again, you're not going to get the old one. So this will be playbacked, but this will, for the first round, this will be playbacked, but this will not. So every time you call this, you do a get to this property, you will get a new result. But if it did already assign to a variable, it's going to be filled in with the old value. I know that's tricky. So this is going to have the old, this is going to have the current, and then elapsed time will be subtracted from 60 seconds. I will wait for, the amount of time needed so that the cognitive services free tier still can serve me. And then I'm calling continue as new with a new list that is left. So let's say I had 20 images, 10 processed. This is the list that has the other 10. And I'm going to say, I'm going to say continue as new, which means, hey, reset the whole story with this orchestrator function. It's going to be the same instance. I don't want you to spin up a new one, but let's consider this is less like, a fresh instance of it. Okay. And give that the list. So what about this? This usually works if I didn't do this. By doing this, by doing continue as new, I'm actually deleting the context of this particular execution of this orchestrator, and that's going to delete the output as well. Here, what I'm supposed to do, and I didn't implement, is, those are the images that have food in it. I have to, maybe you would like to store it somewhere. Go to a SQL or a table storage or whatever, put them somewhere. I just don't have the code. Usually the output is what you can see when you go back and check the status of the orchestrator. For example, here, okay, we don't have that. So remember those endpoints it gave us for the, for example, to call an event on the orchestrator. There's actually a separate URL that says check the status. And when you go to that, it's going to give you the status of the orchestrator, running, completed, and so on and so forth. And it's going to give you an output to JSON as well. So you can, whatever you put here, it is going to be stored as part of that execution context of that orchestrator instance. But again, because I'm doing this data will actually be deleted. So the only the last execution result will be stored. This is buggy. That's what I'm trying to say. Don't store here. This is just an example. And in this case, I will only pass 2 images. So we're not even going to test out the paging, but trust me, it works. Okay. So this is the C# version of doing this thing, right? I can send an array of images and, do it. I'm not going to run this because apparently we don't have a lot of time. But what if I did this with logic apps? We were talking about logic apps, right? So let's look into that. Let me close this. And this time I have another function that only does food detection. It doesn't have the orchestration. It doesn't have anything like that. Okay. And, if I have to change anything about the orchestration, how many, the page size and stuff like that, I can definitely put those into the config. But long story short is that whole flow, if you decide to change the flow, that you have to codify that and do a deployment. But in this case, I have a simple function that only does, that gets the URL in the query string, does image analysis, and returns, if there's food in the image, it returns okay. If it doesn't, it is on still far. Again, don't think this is the example of beautiful API design, but, just for the sake of getting this running, this is what it is. And I have this deployed in Azure right now, and I want to orchestrate this. I want to create another API that can get a list of images and then run this function in parallel, okay? And then bring out back only the foods that have images. So I want to implement the orchestration in Logic Apps. So how would I do that? And there we go. I did it. Okay, I'm going to go into this Logic app and go into the design view. As you can see, it took a lot of experimentation to get it running. Okay, design view, Logic App Designer. So, yeah, doesn't this look beautiful? Okay, so the first thing I got here is an HTTP request receiver. Okay, I got the JSON schema as well, so that it can parse everything. Then let me go down and open this second box. It initializes a variable called food images. It's going to be an array. Okay. Then I can scroll down. So let's do this. I got a for each loop. Interesting. Let's open that one up. In the for each loop, I am passing the body of the initial request up there, the JSON array, as the iteration source. And then in the iteration, I got an Azure function that is food detector. It is already deployed into Azure. And what I do is on the query string, I am passing the current item in this loop with a parameter called URL, right? And then, I'm going to get, HTTP OK to 200 or 204. And, in order to differentiate that, I have a condition. I'm going to open this condition. This condition said, hey, if the status code equals to 200, then append to array variable, append the current item to food images that you initialized previously. If the status code is not 200, then you have not, you don't have to do anything, right? And finally, I'm going to scroll down. We're going to create a response for the logic app, which is going to simply serialize the food images array and turn it back. And that's it. So I got a single function that does the job. To be honest, I didn't need a function in this case. I could actually simply, there's a connector for cognitive services. I could simply connect cognitive services straight. I didn't have to wrap it out with an Azure function, but just for the sake of, showing the integrations, I wanted to have a function that does, that does something else with a third-party API. Maybe it doesn't have a direct integration with logic apps, right? So, and you can have multiple functions like this. You can, if this is false, for example, you can run another function. Those are just going to be separate boxes and parameters will be flying around, right? And I have the endpoint for this here somewhere. Let me scroll down. Food detector. Okay. I guess, yeah, this is it. This is the one. This is the endpoint. And then I'm sending two images. One of them has food. The other one doesn't. And I will send a request to this. And let's wait and see what happens. Yeah, there you go. We got one image back. This one has food in it. And let me prove you that it's actually running the Azure function, right? So first off, I can prove you here that there's going to be an execution that is succeeded just now. And I can go back actually to my function orchestration resource group. And this is the function I used. So let's go into the function and let's go down. Where was that? Okay, log stream. So this is going to connect real time to the Azure function, connected, cool. So I'm going to call the logic app. So from the endpoint, you can see that this is the logic app because this is actually the function runtime endpoint. I'm not calling that. I'm going to call this. So I called the logic app again. Let's go back to the portal. And there you go. So we sent two images. And if we look at here, we're going to see no food found. Okay, typo. Food found in this, the image that comes from Squarespace, and no food found in this one. So I expect the Squarespace URL be in the response from the logic app. And yes, I'm not going to click on it because I'm still on diet and I don't want to see food. Okay, cool. Great. So this is how you do orchestration in Azure Logic apps. This is pretty easy and straightforward. And, you have a bunch of connectors as well that is the thing, I guess, that has a lot of value as well. I could have connected this to Office 365 Graph API and stuff like that. And all those connections, if you decide to build them from scratch, it takes a not so useful amount of time, to be honest. The return on investment on that time, I'm not sure if it's worth it, especially if you're, I don't know, up to you. But I like it. orchestrating functions from Logic apps. We did look into that. Got it. Okay. And here we go. Let me put it here. So here are a couple of links I wanted to share. The workflow definition language for Azure Logic apps. Why would I share this? So the designer, I know it looks good and sexy, but sometimes it might be a pain in the neck. So in that case, you might want to, there's a code view and you can even connect it to a source control. But, sometimes you might need to go into the code and, like every markup editor, right? UI. Sometimes you have to go back and look at the code. So the definition language, having the schema there can be helpful. In case you're interested with the durable task framework, now that you saw all these awaits and tasks running around and wrapping HTTP calls and stuff, this is the link to go. Durable functions NuGet package. In case you want to add it to a current project that you have, here's the URL, and you can definitely search it on the NuGet package manager as well, of course. And if you create a new function app, it comes by default anyways, but still I wanted to put it out there. Okay. I guess with that, that's all I have. Here's the link to the slides. This is where you can download the slides. And again, feel free to reach me out if you have any questions. And right now, we do have some time for Q&A. Like 3 minutes or what? Do we have any questions from the room?
Thank you, Darren, for your beautiful session. I get a question. Is there any other trigger available for the orchestration other than HTTP?
So the orchestrator, we run it, remember we call it manually from C#. The connection between the thing that starts the orchestrator and the trigger is totally up to you. For example, I could have a timer trigger in Azure function and put the orchestrator, start new orchestrator code in a timer trigger, and I would simply be spinning out new orchestrator instances every minute or two. You can use any trigger that is available in Azure functions to kick off an orchestrator. And the amount of triggers available in Azure functions are like crazy. There's like, blob trigger, queue trigger, and all that stuff. So it's just a matter of you build whatever trigger you want to use from an Azure function, just put that in, simply execute, start new orchestrator, and that's it. That's the only connection between the two. Cool. That was a good one. Anything else? Did I do a beautiful job explaining everything and there are no questions?
I have a question.
Okay, sure.
So how do you go about versioning? Let's say the orchestrator is running for some long-running operations and you roll out a new version of your functions. Now half of the orchestrator ran the half version, second half runs the new one.
Beautiful. One solution for that I didn't talk about that, but you can have orchestrator hubs, so you can separate those. You can have, but still it doesn't necessarily solve your problem of what if my new version is not able to, for example, handle the state of an old one, right? There's nothing that's going to help you out. You have to take care of that. There's nothing that comes out of the box that is going to help you out on that side. Yeah, it can be really tricky. Not really a very helpful answer. Sorry about that. Okay, so this is me from the future. Just edited this in. And here's a document that relates to that question, and I will just kind of explain, kind of give the same answer in the session and the video as well. But when it comes to versioning in durable functions, again, to be honest, there isn't a lot. This is the official documentation. I looked it up in case there was something that I'm missing. So they're simply listing the type of changes that you might do that might cause problems. And then here are the suggestions. First, do nothing. Not recommended, definitely. So the person who wrote this documentation, I guess he had a nice sense of humor, the naive approach. Okay, there's a nice explanation though. I should give them the credit. And then stop all in-flight instances. Yes, obviously. Side-by-side deployments is what I'm gonna say next in the live session. Deployment slots can help with side-by-side deployments as well. But overall, when you look at it, there isn't really the control queue and the work item queue, you can clear those up. My suggestion about picking a separate hub can actually help with that. And I noticed that I mentioned like function hubs. It's not necessarily a function hub, it's a task hub, what I'm referring to. Task hubs help you separate the environments within a single storage account, or you can actually have multiple storage accounts as well. There isn't any difference between the two other than logistics. So I want to add that while I was editing the video, the recording of the live session. But if you want to have, side by side, you can use the hub concept for orchestrators. And, obviously you can even do separate because the connection to all that state and all that stuff is actually, if you go with the default Azure storage, it's just a storage connection string, right? So you can even partition on that front, and you can have multiple. Oh, that would be interesting. No, that would definitely go into multiple deployments, which is not what you want, right? You're talking about migration, so there isn't a lot that would help you on that front, unfortunately.
So I have one more question. Is there any fault recovery built into the orchestration? Let's say if the internal request got throttled or something like that, and I want to repeat it again in a while. Is there any way?
Yes, there's some retry logic already embedded into the system, and you can configure those. And there's this file called host.json. You can configure some of those parameters in there. Definitely look up for the documentation for that. Okay, here's another jump from the feature. First off, this is the one that I wanted to mention, call activity with retry async. This is specifically about the durable orchestration, durable functions. You can give it, the function name and then the retry options and stuff. So there isn't an example here, but you can definitely find some examples if you Google it, I'm sure. So this is one thing. And the other one that I was referring to, the host.json file here, has, and let me go down there, some retry stuff in here as well. And what are they used for? Let's jump here. These are going to control the retry policy for all executions in the app. Again, you can define the strategy with max retry account, delay interval, minimum interval, maximum interval, and so on, so forth. So those two can be helpful to help with that problem. But if there's a fault in terms of the whole, the whole system, right? Something is failing that cannot be, restored or whatever. In that case, yes, you're going to need to go into application insights. So all of the operations and the additional metadata related to the operations as well is being logged into application insights. So if you go into application insights, you can see things like, this function orchestrator is running for a playback, and this is why. So there's additional metadata pushed through the logs into app insights if you are using durable functions. So that can be helpful.
Okay, cool. Thank you very much. This is probably all from us. Thank you again for your session.
Thanks, everyone. This was beautiful. I wasn't there. I hoped to be in Prague, but hopefully next year. Yeah. See you. Have a beautiful rest of the conference.